Hello everyone! In this lecture we will study lattice towers, which are commonly used in power transmission and communication systems. A lattice tower is a framework structure made of steel members connected together to form a strong but lightweight structure. Because of its open framework, it can safely resist wind loads while using less steel. In this lecture we will learn about the applications, parts, design considerations, erection methods, construction sequence, and safety precautions followed during lattice tower construction. A lattice tower is a freestanding framework tower made of steel members arranged in a truss pattern. The open framework reduces wind pressure and provides high strength with less material. Lattice towers are widely used for high-voltage electricity transmission lines, usually above 100 kV. They are also used as radio towers to support communication antennas, and as observation towers where people can safely view surrounding areas. Their lightweight design makes transportation and erection easier than solid structures. A lattice tower consists of several important parts. The peak is the topmost portion of the tower. The cross arm supports the electrical conductors. The cage provides stability near the upper section. The tower body forms the main framework. The boom strengthens the structure, while the legs transfer loads safely to the foundation. At the bottom, the stub, anchor bolts, and baseplate assembly firmly connect the tower to the concrete foundation. Every component has a specific function to ensure stability and safety. Here we see the arrangement of the different parts of a lattice tower. Observe how the steel members form a triangular framework. Triangular shapes are commonly used because they provide excellent stability and efficiently transfer loads. The cross arms support the conductors, while the legs transfer all loads safely into the foundation. Understanding this arrangement helps engineers during fabrication, erection, inspection, and maintenance of transmission towers. Several factors are considered while designing a lattice tower. First is the minimum ground clearance, which ensures that conductors remain safely above the ground. Second is the maximum conductor sag, which increases with temperature and loading. Third is the vertical spacing between conductors, preventing electrical flashover. Finally, sufficient clearance between the ground wire and the top conductor must be maintained. Considering these factors ensures reliable electrical transmission and public safety. Construction begins with the tower foundation. First, the site is excavated according to the design dimensions. A layer of plain cement concrete, PCC, is placed as the base. Stub members are positioned accurately using templates. After checking alignment, concrete is poured around the stubs. The concrete is then cured properly to achieve the required strength. Finally, the formwork is removed, and the excavation is backfilled. A strong foundation ensures that the tower remains stable throughout its service life. This image shows a stage in the construction of a lattice tower foundation, where the structural base and legs are being prepared. There are 4 common methods of erecting lattice towers. The build-up or piecemeal method assembles individual members one by one at the site. The section method lifts larger pre-assembled sections into position using cranes. The ground assembly method completely assembles the tower on the ground and then lifts it into position. In remote or mountainous regions, the helicopter method is used to transport and install tower sections quickly where cranes cannot reach. Rigging is the process of installing ropes, lifting equipment, and temporary supports during tower erection. The sequence starts with mobilizing equipment and workers to the site. Next, the site is prepared, followed by completion of foundations and underground works. Major structural members are then erected carefully using suitable lifting equipment. Throughout the process, strict safety measures must be followed to prevent accidents and ensure successful construction. Safety is extremely important during tower erection. Safety nets should be provided when workers are working at heights. Construction must never be carried out on live transmission lines. During rigging operations, only authorized workers should remain in the work area. All wires must be properly anchored and strong enough to carry their own weight and withstand temperature changes. Regular inspections should be conducted to identify loose connections, damaged members, or unsafe conditions before continuing the work. Let us summarize today's lecture. Lattice towers are lightweight steel framework structures widely used for power transmission and communication. Their successful construction depends on proper foundation work, careful erection methods, correct rigging procedures, and strict safety precautions. Understanding the different parts of the tower and the factors influencing its design helps civil engineers ensure safe and durable construction. Thank you for your attention.